Welcome and thank you for standing by. At this time, all participants are in listen-only mode until the question and answer session of the call. To ask a question during that time, please press star followed by number 1. Today's conference is being recorded. Any objections, you may disconnect at this time. Now I'd like to turn over the conference to Josh Finch. You may begin.
Good evening, and thanks for joining us for today's media teleconference following the first docking of Boeing CST-100 Starliner spacecraft to the International Space Station as a part of NASA's Commercial Crew Program. I'm Josh Finch with NASA's Office of Communications. Joining me to talk about Starliner's journey to the space station is Catherine Leaders, Associate Administrator for NASA's Space Operations Mission Directorate, Steve Stitch, Manager, NASA's Commercial Crew Program, Joel Montalbano, Manager, NASA's International Space Station Program, and Mark Nappy, Vice President and Program Manager, Boeing Commercial Crew Program. We'll open it with opening comments from our speakers, and then we'll turn it over for media questions. And first, I'll start with Kathy.
Thank you, Josh, and thanks for all of you that are hanging out there and waiting to hear from us. You know, I don't know about you, but the last few hours have been excruciating. You know, seeing that beautiful spacecraft sitting right out of reach of ISS was pretty tough. But as we've talked about over the last few days, this was a really critical demonstration mission. And it was important for us to get that demo data and get the learning from each of the steps along the way and really put the vehicle through its paces. And so sometimes that journey takes just a little bit longer, but for this joint NASA and Boeing team that has worked so hard on getting to this point, seeing that vehicle dock now to the ISS is just phenomenal. And I know for the next presenter, Steve Stitch, it's a fabulous birthday present for him. So I'm hoping that after getting a good night's sleep, maybe a few hours here, the team, will be getting ready to really open the hatch tomorrow, and then we'll be getting ready to do the few checkouts we have on orbit, and we'll once again be looking at the weather for a return and bringing that capsule back. Because as we've talked about a ton, we've learned so much from this mission over the last 24 hours. And the data that we're getting from this mission and really fully checking out these systems and all of that learning is going to be helping us get to our ultimate goal of flying our crews on this next flight. So I can't tell you how incredibly proud I am of the joint NASA and Boeing team, in particular the NASA flight ops team that is working with Boeing, and all of the folks out there that have done so much to get us here today. I really appreciate all that they've done, all the hard work. We still are only part way through this demonstration mission. Still got to get the vehicle home, but what a great day for this. And let me hand it over to Steve Stitch, who's done a crap load of work to get us here and is spending his birthday in the control center. So, Steve?
Thank you, Kathy. I've had an incredible 24 hours with today being my birthday, and at the end of the day today, I had to wait a little longer for my birthday present. It was well worth the wait to have Starliner dock to the International Space Station. And it was just an extraordinary day on behalf of the entire Commercial Crew Program. I'm just thrilled to be here on my birthday, welcoming the Starliner to the space station and watching that vehicle come in and dock. It's very historic for Commercial Crew. Our goal was to have 2 redundant crew transportation systems, and now, that's been our goal since its inception, and today that goal became true when Starliner docked. And I was super proud to see Starliner come in and have the Crew Dragon there, along with the crew-capable Starliner spacecraft, both there at the space station together. So it was just a great day to see that. Of course, this is a test flight, and as those that probably watched through the day, you saw that we were learning along the way, and it's very exciting. We tested the VESTA system, which is the Vision-Based Electro-Optical Sensor Tracking Assembly. Try to say that 3 times fast. And great system that Boeing developed, and we tested it today as we docked. That system really uses all of its cameras and LiDARs and sensors to figure out the range and the proximity to the station, and then it uses that information to fire the thrusters and come on in, and that system worked great today. We had, a few funnies with a few sensors along the way, but the system has tons of redundancy, and it did a wonderful job flying the vehicle on in. Today we tracked a few things that we worked, I would say, since we last talked. Yesterday we talked about the 2 OMAC thrusters in the port doghouse. We just deselected those thrusters today. We didn't use them for 2 of the rendezvous burns that we performed with the OMACs, and so we're in a good config for the next burn that we'll do with the OMAC system, and that will be the deorbit burn. So we had a challenge with liquid cooling loops. There's 2 of those cooling loops that flow out to the radiators on the service module, and that provides cooling to Starliner. We saw some really low temperatures in a couple of those loops, and then the pressure coming out of the pump on 2 of those loops when we were in a really cold attitude went up. The ground team did a great job of managing those loops. They were able to bypass or eliminate the flow into the radiator and use those loops and manage those all throughout the rendezvous. And we got comfortable with that system, and we were able to come in and dock. We had a couple of reaction control system. Those are the small thrusters that shut down today and looked like they were just a low chamber pressure. We have a lot of redundancy. That really didn't affect the rendezvous operations at all and won't affect the rest of the flight. And so I know after the flight we'll go study the failures there and see what happened. Today we also tested for the first time the NASA docking system, which was built by NASA and used for this flight. We learned a lot about that system as well. I would say we had to slowly reboot a redundant side of that system to bring it back in parallel to the A side of that system, and that system worked beautifully today for the very first time. Docked very softly to the station, and then we were able to retract the 2 vehicles and then get the umbilicals hooked up to provide power across the interface. We'll open the hatch tomorrow, and the ISS crew will start checking out the Starliner. That'll happen at around 11:45 Eastern. There'll be a lot of activities once we open the hatch. There'll be a joint ventilation test with the ECLA system from ISS, some communication checks, cargo transport operations into ISS, and then we'll check out the laptop system as well. Again, I want to thank the entire NASA Boeing team. A lot of resilience demonstrated over the last few years and really the last 10 months at getting to flight. The Starliner has performed beautifully. It's got a great crew transportation system. I think this flight so far has demonstrated that. As Kathy said, we have more work to do to undock and do the docked test objectives and then land. It's an incredible moment for our team. We'll take it one step at a time and look forward to landing Starliner next week. And I'll turn it over to Joel.
Hey, thank you, Steve, and thank you for joining us today. It's great to have another vehicle capable of delivering crew docked to the International Space Station. As we talked about the crew on board, they did have some pre-planned commanding to the vehicle. That worked without issue, and the ground control teams were in constant communication with the crew as we worked those last few items in preparation for docking today. So constantly talking to the crew and no issues. The vehicle really performed nice, and like I said, it's awesome to have another vehicle docked to the International Space Station. Steve mentioned the hatch opening tomorrow, and so we're looking forward to that. This mission will stay docked to ISS for about 5 days, and pending weather, that's when they'll come home middle of the next week. However, if weather's not cooperating, no issue with that vehicle staying longer, and we're ready to keep them docked as long as required. Following this vehicle, as we've talked about, we'll have the Progress changeout. We'll have a SpaceX 25 cargo mission, and then a Russian EVA later in June. So with that, a huge thanks to the Boeing program, the Commercial Crew Program, the International Space Station Program, all our international partners, as people have done a huge amount of work to get us to today, and just a huge thanks to everybody. With that, let me hand it over to Mark.
Thanks, Joel. It's another great day with the docking of the Starliner to the International Space Station. really amazing teamwork. It's a seamless, integrated team that is just incredible to watch. Special call out to the flight operations team that works in conjunction with Boeing on our program to run our mission ops. It really is an excellent example of how we can work together in this environment. The technology around Vesta is really amazing. It was really something to watch, and it was really nail-biting watching that vehicle sit out there for a little while until it was time to come in. So a lot of very happy folks in the Boeing program today because of what we saw. The OFT-2 was, it's a test environment. It's a test flight, I should say, and we intended to learn a lot from this. With that, what we learned, we take that information and we apply it to future missions and the development of our spacecraft. We're very satisfied by what we've learned, how the team has reacted to it, and how the vehicle has responded to some of these items that Steve talked about earlier. A couple items of interest that he mentioned was the OMAC shutdown, the liquid coolant loop pump delta P, the RCS system issues that came up. All of those were responded to incredibly well by the team and the hardware. So we developed plans when those problems came up. We teamed with the crew office, the NASA crew office, and ISS, and we implemented those plans with a lot of success. So we're really looking forward to continuing the mission tomorrow, getting the hatch opened up, and then getting on with a handful of demonstrations, and then undocking here in the next 4 or 5 days. So thank you. Turn it back over to Josh.
And thanks to all of our speakers, and we'll now turn it over for the media question and answer portion. To get into the queue, please press *1 on your phone. And our first question will go to Bill Harwood at CBS News.
Hey, thanks, guys, and appreciate you staying up after a long day to talk to us. I had a quick question about cooling loops. Not sure who to, but Steve, you mentioned low temps and pump output. Did you get ice in the system? And like I remember happening on a shuttle for a few occasions, and did that affect both loops? I was just wondering if they both froze up. And if so, what were your margins for docking? I mean, you said that you were able to go ahead and dock anyway, but how close was it? Thanks.
Yeah, Bill, thanks for that question. The loops are similar to shuttle. The fluid in the loops is something called Golden, and it's a little bit like Freon. So think of this as like the Freon loops for the space shuttle. What we saw was we might have had, and we're not really sure exactly what happened, we might have had some moisture in the loops that as the temperatures got colder in these colder attitudes, some of that moisture may have come out of solution and maybe got in a filter and blocked that filter a little bit. So when that happens, the pressure, the delta P coming out of that pump would go up. So what the team did, and I came right from the launch, landed here, came right to the control center, and I got to watch Tim Wright and the Boeing team work with the flight ops team, as Mark talked about. And they did an incredible job of really looking through what the data was showing them. It was on both loops. One was a little more severe than the other. They worked a plan to bypass the flow through the radiator. The radiator is where you take the warm fluid coming out of the vehicle and it cools it down. They were able to bypass those radiators, warm up the fluid. The loop recovered very quickly, and then they used that technique on both the loops at various times to manage the whole docking sequence today, and it worked really well. So, and when you ask about margin, Bill, we had plenty of margin to manage. Both loops were operational. We didn't lose a loop at all. They were both performing really well, and this innovative technique of bypassing the radiators really saved the day for us. So.
Thanks.
And our next question is from Chris Davenport at the Washington Post.
Hey, thanks, and congratulations, and happy birthday, Steve. Quick question on the OMAX, I guess for Steve or Mark. Do you have any idea at this point why the chamber pressure dropped in those two thrusters, and was that at all related, or did you have a similar problem, I guess, with the RCS thrusters? And also, just given the long road to get to this point, I wonder if you could just take a moment to describe the emotion of those tense moments leading up to the docking, and then finally having Starliner on the station. Thanks, and again, congrats.
I'll start with the question on the OMAC thrusters. The team today came back and gave us a really nice rundown of what they had done with respect to the fault tree to try to understand what the potential causes were. They listed maybe 6 or 7 different causes, and there were several that were highly unlikely based on the data that they pulled, and then there were 3 or so that looked to be plausible. So, we may never know what the real cause of this is because we don't get this vehicle back, but we at least have done our homework and we understand what the potential causes are, and then we'll apply that as we go forward. So I don't want to narrow in on any one cause because, we won't know. We do have to make some decisions to activate those for recovery, or for after undocking, to use for the rest of the mission, and depending on how they behave, they may give us more information. Steve, you want to add anything more to that?
No, I don't have anything to add, Mark. I will talk about the emotional part for me, and I'm not much of an emotional guy, but it was emotional for me today to watch Starliner coming in, and as I watched the vehicle flying a flawless approach, I just thought of the team, really, and how much everybody had worked so hard for so many years. I've been a part of this program for almost 7 years, many people a little longer, and just thought of the people. And then at the end of the day today, we got to go around and shake some hands and talk to some of the people that had worked the first flight as well, and just see the excitement on their faces and how thrilled they were to see Starliner dock, to see it fly flawlessly, to meet this objective of getting to docking. It was just awesome to see, and what an incredible birthday present it was. So.
I'll add to that. I've not been on the program that long, but walking around and talking to the people both here in Houston and before I left Florida yesterday for the launch, and just a lot of very proud people and feeling very good about the product that they've spent so many years putting together and wanted it to be successful. So for me, it's very gratifying. Come in at the last minute and be able to see something like this is really incredible.
Thanks.
Our next question is from Jeff South at Space News.
Hey, good evening. Thanks for doing this. For Mark, I know you don't want to go into many technical details yet about the OMAC thrusters, but do you have any insights about why it affected 2 thrusters but not other thrusters? It doesn't seem like it's a completely isolated problem. And then for Steve, looking ahead to undocking, do you have any sort of long-range weather forecast to help you guide when undocking and landing might take place? Thanks.
Yeah, when I talked about the fault tree that the team went through, they did look at common cause to see if there were things that made sense that could cause both. Many of the solutions or the causes that they came up with were, it was unlikely that there was a common cause there. So it might be that we saw just 2 non-related items that caused both those thrusters to shut down like they did. So we'll carefully look at this after the mission, and we'll apply our lessons learned to the next vehicle.
And let's see, our plan to undock would be as early as May 25th. That's a landing at the White Sands Space Harbor at around 6:46 p.m. Eastern. I'll be honest, I have not looked at the weather at all yet. We'll start doing that a little bit over the next few days. We were really focused today on the rendezvous and testing the Vesta system and the NASA docking system and getting docked, and so we'll go start looking at the weather and see if it's acceptable for landing. If it's not, we'll find the right time to go undock. Joel has offered to let us stay a little longer if we need to, right? So we're not in any hurry to come back. We want to learn as much from this vehicle as we can while it's on orbit, and then we'll take a little bit more of a look starting next week at the landing sites.
As a reminder, if you'd like to ask a question, please press star 1 on your phone to enter the queue. And our next question will be from Stephen Clark at Spaceflight Now.
Thank you for doing this. Stephen Clark from Spaceflight Now. Congratulations to all of you, and happy birthday, Steve Stitch. Just wanted to follow up a little bit on an earlier question about how close of a call was this with your margins. Someone asked about margins with the thermal control system loop, but the Starliner was waiting at the 10-meter hold point quite a bit longer than expected due to the NDS issue, and then I guess for perhaps lighting optimization. But how long could the spacecraft have stayed at that hold point? If you missed that second docking window, was there a third window available, or would the spacecraft had to have backed away and come back sometime later? Thanks.
Yeah, we ended up holding at that 10-meter point a little longer than planned. We had always planned to hold there to set up the lighting to be proper for the approach and docking. Really what we want to do is for certain sun positions, the docking target itself can get kind of dark, and we wanted to have the lighting really good for the crew on ISS to monitor it. We could have sat there certainly multiple revs. We had plenty of propellant on board. I don't remember the exact number, but we could have sat there even longer. And I think there's a lot of learning, really, on how to manage the NASA docking system. For example, we ended up having a bit of a problem with the backup system, and so we had to think about rebooting it, powering off a couple of pieces of avionics. And when we did that, we had to go drive what's called the soft capture system of the ring. We had to drive it back in and then back out. That took a little time, and then we waited for lighting and came on in and docked. So it was, a little more excitement than maybe we wanted to sit there, but, and at the end it was safe, and I think we learned a lot from it on both ops and engineering teams.
I think to address your first question and add to a little bit more of the coolant loop problem that we had, first of all, we didn't really reach a failure point. The team caught this before we had any real problem there. They really saw some warning signs of the pump pressures going up, which indicated that we may have had a coolant loop that was getting the golden, either with ice in it or just the density of the golden was getting thicker. So the team responded really quickly, and we were really never in any trouble. And because of the way they responded, they kept us out of trouble.
And our next question is from Kenneth Chang, The New York Times.
First is for Steve Stitch. Since everyone's wishing you happy birthday, I was wondering which birthday is it? And I was wondering if you could give some more details about the RCS thruster issue. When did it crop up, and what have you diagnosed so far? Thank you.
It is my 57th birthday, and so I'm very, very happy to celebrate that birthday today with our team here in the Control Center, and it was a great day. In terms of the RCS thrusters, those just ended up, they were firing fine. They had multiple firings, and for whatever reason, it looked like the chamber pressure, which is a measurement that's used to tell the software whether that thruster is good or not, went very low, down to 0, and then when that happened, the software did the right thing and took them out of the algorithms to go fire them for approach and docking. So I don't think we know quite yet. It just happened today. I don't think we know quite yet what happened to those thrusters, but the vehicle has plenty of redundancy and has plenty of redundancy also for undocking and landing, and those thrusters are also used for the disposal of the service module, and we still have plenty of redundancy there. So.
Was that during the final approach or earlier?
It was not during, it was at various points during the approach. I didn't write down the exact times, but there were a couple of those RCS thrusters that failed today during the approach operations. It was really after we got into what I would call integrated operations that the thruster shut down. So.
Thank you.
And our next question is from Micah Maidenberg at the Wall Street Journal.
Hey, everybody. I think this is for Steve and or Mark. Just assuming everything with the rest of the mission comes off as planned, could you talk about sort of the investigation into the OMAC thrusters and some of the other issues that cropped up? How does that continue kind of on the ground after the fact, and what kind of effect, any thoughts on any effects that could have on the schedule for the first crewed flight test? Thanks.
Yeah, I'll take that. It's Mark. A part of our process is to document anything that is a funny or an in-flight anomaly, and actually that's what we call them, in-flight anomalies. And we take those and we investigate those down to some type of root cause, or at least narrow it down to a few root causes for engineering. It's engineering analysis, and then we decide on what we're going to go do. So there'll be a very detailed corrective action type of investigation that will be performed, so we can determine what we need to do. Then we'll plan that into the flow, and we've already got time set aside for these types of things that will happen. We know that they happen, we just don't know what they're going to be, so we just set a amount of time aside so that we can address them when the vehicle gets back.
And for example, one thing like with the liquid cooling loops, that the crew module comes back and the loops are sitting there, we can take samples of the fluid and see is there moisture or something in there that maybe was part of the cause of the low flow and the high delta pressure. So that's one example of the kind of things that Mark and the team will do. So.
And any thoughts on schedule? Sort of, Mark, you said that some of that work was built in.
What we do is we just set the time aside, knowing that we're going to pick some things up in flight, and it'll result in X number of hours in the flow. So we just set that number of hours aside, so that when we do come back, we just plan it in to the normal flow, the normal process. And actually, when we know going into the flow that these things are out there, they're very easy to plan in.
And our next question is from Marcia Dunn at the Associated Press.
Oh, hello. I think you answered it, Stephen, by the way, happy birthday. So were there like two of the smaller thrusters that failed today? So for a total of 4, 2 yesterday, 2 today. And for Mr. Nappy, I'm just wondering if you finally think you're going to get some sleep tonight.
Yeah, let's see. We ended up having 2 of the OMAC thrusters, which were the bigger thrusters that shut down yesterday during the orbit insertion burn, and then we ended up having actually 2 of the smaller reaction control system thrusters that shut down today. So a total of 4. 2 of the smaller ones, Marcia, and then 2 of the larger ones. I think there's a question for Mark. I'm so tired, I'm not quite sure I'm catching all the questions. So.
Yeah, I think the last 48 hours has just been a barnstorm, so it's going to be very easy to sleep tonight, and I'm sure everybody around this table is going to have no problem sleeping tonight.
And our next question is going to be from Tom, but they were not able to get into the question queue, so I'll ask the questions for Mark. What was the environment inside Starliner like for the duration of the flight? Was it at a comfortable level for crew as expected, and any surprises there? And then for Joel, what on-station tests will be done for Starliner while it's docked at ISS to evaluate it for crew access? And will the ISS crew be able to keep hatches open, go inside, and even sleep inside for tests?
Yeah, we monitored the temperature inside the crew module and had some good readings on that. It's interesting because the lack of the crew may have contributed to the golden problem that Steve talked about, because with nobody there to generate a little bit more heat, the system just got a little bit colder, because it uses the heat from the crew module to actually keep its temperature down. So the vehicle performed very well, and we'll certainly spend some time understanding what happened and go into that system and correct it.
And on board while the vehicle is attached, we'll do some environmental samples of the vehicle. We'll also do a communication test, testing out the communication systems between the two vehicles. For this mission and for future missions, at least at this time, there's no plan for anybody to sleep in the vehicle. And so the crew members will continue to sleep in their crew quarters. We also, as we talked about, we're delivering about 500 pounds of NASA cargo and returning about 600 pounds. And so we'll have a test of that. We'll be unloading the cargo that was brought up by the vehicle. And then before it departs, we'll be reloading cargo into the vehicle for the return back to Earth.
Thank you. And our next question is from David Curley at the Discovery Channel.
Thanks, everybody, for doing this. I joined late, so if this is repetitive, I apologize. Mark, what was flapping on, I guess, was doghouse for our looking at it, it was the top doghouse, there was something flapping. And Steve Stitch, I'm told that spacecraft have personalities. What is the personality of this spacecraft? Does it? Do you have a sense of it already? Thank you.
Well, I'm glad I got the first question. The thrusters themselves have thruster covers on them, and they're really rain covers, so they're really needed for the ground. So we put this paper over them. It's called butcher paper is what it's called, and it's like a plastic so that it protects any rain from going inside the thrusters when we're outside. They blow off normally when the thruster fires, and sometimes they blow off when during ascent. And so these, I'm not sure if they came loose during ascent and just blew around, or that once the thruster fired, they tore off. But they're designed to do that, and it's perfectly normal.
Yeah, in terms of personality, it's probably dangerous for me to answer the question after having, like Mark said, not much sleep in 48 hours. But to me, this spacecraft just seemed to be patient and took everything in stride. And when I watched it perform today, it patiently took everything that was thrown at it by Mother Nature or whatever, and just endured those things that happened and sat there and flew flawlessly. And when it was time to execute the final rendezvous and approach and docked, it patiently did that. So that's the thing that comes to mind here late on a Friday evening. So thank you.
And our next question is from Jackie Waddle at CNN.
Hey, everyone. Thanks so much for doing this. So I wanted, I'm sorry if I missed something earlier, too, that might have been germane to answering my question, but I was hoping you guys could walk through a little bit more in layperson terms, like why we won't know the root cause of the issue with the thrusters. And I think something was mentioned earlier about you won't get the spacecraft back. Was that just a reference to something candid, or was that something more technical? Thanks so much.
Yeah, this is Steve Stitch. I can take that question. That the spacecraft is really in two major components. There's a service module that has all the propulsion. It has the launch abort engines that, should we need those, or pad aboard, or that early stage in launch. It has these orbital maneuvering thrusters, which we talked about shutting down on the orbit insertion burn, and it has the reaction control system thrusters. What happens is the service module does all the rendezvous burns like we saw today. It flies in and docks, and it then executes the orbit burn. And once it does that, its mission is really over, and so it separates from the crew module. The crew module has a set of thrusters that go and maintain attitude during the atmospheric flight and entry and landing, and then the service module ends up going through the atmosphere and burning up. And so what Mark is talking about is we won't get that hardware back. We won't get those thrusters back on the ground to take a look at those. So we have the data that we had in flight. We'll be able to look at that data. We may be able to dump some more high rate data. We will look at the fault tree. We may be able to do, if we need to, some testing with the thruster, but we won't get those specific thrusters back because they will burn up during entry.
And our next question is from Ken Kramer at Space Up Close.
Oh, hi. Thank you for doing this. Congratulations to everybody, and Steve Stitch, too, on your birthday. So on the fun side, Steve, I wonder if you have if you're going to celebrate with a special birthday cake that might be Starliner related. And on the serious side, I want to ask about the EVA suits. Since EVAs are on hold now, I'm wondering, can you talk about hardware that's going to go up and down to find out what is wrong and replace them? And do you have any spare EVA suits on the ground that you can send up sometime? Thank you.
Yeah, I'll address the cake question, and then I'll let Joel talk about the spacesuit. But we had cake here with the team right before I came down. That was one of the things that I got to do, is celebrate with our joint NASA-Boeing team, and it was great to have some birthday cake, but it was even greater and more special to have Starliner dock to the space station today. And Joel can address the spacesuit question.
Hey, Ken, thanks for the question. You know, on the spacesuits, a couple things. On this mission, we flew some absorption pads that we'll be doing some testing on orbit. These will be some absorption pads to complement what we already have in the suit, where the vent loop comes out in the back. And then we also have an absorption pad we're going to put on the top of the helmet to collect water that misses that little area in the back. So we'll be doing those tests. What we'll do is we'll do some tests on orbit with some water in the helmet. If you were watching some video today, we did some preliminary testing with the helmet and water, but we'll go ahead and use the material that we brought up on the Starliner vehicle. As far as spare suits on the ground, you know, our goal is always to have 4 suits on board. And so we'll be bringing the suit that Mateus wore. That'll be coming home on SpaceX 25, and then we'll be working to get another suit on board. So the process is always to have some suits in development, such that we're always when we switch a suit out and bring one home, we want to have another one ready to go, if not already on orbit, before we bring that one home. And so that'll be the plan that we'll continue and work throughout the summer.
Thank you.
And our next question is from Manuel Mandali at Debate.
Hi, how are you? Manuel Masanti, covering the space program in Spanish. Congratulations to the entire team. My question is regarding tomorrow's hatch opening. Are we going to be able to see live when astronauts get on board the capsule?
Yes, the answer is you'll be able to see that. And again, from a time standpoint, 10:45 Central or 11:45 Eastern. But that is the plan, to have a live that so that everybody can see this great vehicle that we just docked to the International Space Station.
Thanks.
And our next question is from Stephen Clark at Spaceflight Now.
Thanks for coming to me again. I hope I have 2 easy questions, I hope. For Mark Nappy, just a bit of trivia to follow up on an earlier question from another reporter. Do you know roughly what the temperature was inside the crew cabin throughout the flight up to ISS, or at least approximately, just to, say it was comfortable if astronauts had been on board? And I know you have 5 possible landing locations for Starliner in the western U.S. I know you're targeting White Sands for this mission. Are you definitely going to be returning to White Sands, or do you have a backup landing site if, the unlikely event that weather at White Sands is unfavorable for a series of days? Do you have a backup location? Thanks.
All right. The temperature inside, I don't recall the temperature at each temperature sensor location. There are several temperature sensors in the crew module, and some of them are behind fans or near boxes that create a little bit of heat, and then some are out in the center. So there was a variety of temperatures, and I don't remember what the temperature was around where the astronauts would be sitting, but we can certainly go find that out and let you know what that is. Along on the landing sites, I believe we have 2 opportunities for the standard landing on the 25th to land at White Sands. So our first 2 opportunities, and then our backup landing site is Wilcox.
And our final question is from Tariq Malik at space.com.
Hi, thank you. Actually, Josh asked my question earlier due to a phone issue, but I do appreciate the extra time. Then happy birthday, Steve.
Yeah, thank you.
All right, and with that, I'll go back to Kathy Liebers for some closing comments.
I think one of my favorite parts of this press conference has been us all wishing Steve happy birthday. And Steve, you're 57 years old in human years, but maybe 100 years old in CCP years. Seriously, sitting through these missions, really, as you sit there, they really provide us a moment of reflection. And, there's amazing amount of blood, sweat, and tears in these vehicles. And just sitting there, it reminds me of, the analysis that we did to put that bypass loop in that thermal system, and really glad it's there, and all the testing that went into understanding the NDS system that helped us today be able to reset and go back in, and all the work done on those thrusters and the hot fire testing at White Sands, and all the work at all the Boeing facilities and the NASA facilities that have gotten us here today. And really, all of us here on this call are privileged enough to be representatives of that expanded team of industry partners, NASA, ISS, commercial crew. I'm glad Joel brought up the international partners that have all been working together to get us here today. And I hope they're all just looking at that beautiful picture, seeing Starliner on the ISS. So this team gets to enjoy it tonight, get some sleep, but tomorrow we'll be back at work and really making progress to our next step, which is to take this learning and to apply and to continue that process that we started so many years ago and keep making progress until we've achieved the goal, which is to have our second crew transportation system to the ISS. Today was a great step toward that. I'm very grateful for the team we have. Thank you for enjoying this day with us today. We got more to come, but this was a great step along the way. Very, very proud of my team, very proud of the Boeing team. I think we got the best here, and I really appreciate it. Thank you.
And that's going to wrap things up for us here tonight. We'll have more on this important flight test to come, including coverage of Starliner's return home. So follow us online, social media, and NASA television. And learn more about the mission at nasa.gov/commercial crew. Have a good evening.